And so anyway, I got this funny mix of different desktop environments. So you can start part of one desktop environment from another. A desktop environment, though, I don't explain that term in Linux usually. Yeah, I should tell them about desktop environments. Maybe I should tell you guys about desktop environments. This is operating systems class, right? Desktop environments are an integral part of an operating system.
Like Windows 10.
Well, yeah, it's an integral part of Windows 10. I hear nobody appreciates that it is, but you know, it is.
Is that most things usually get worse when you make some end of threat poison?
Well, no. I mean, if it's like something that's intended for rats to eat, then that will improve it, at least in terms of function. And I bet it tastes fine. Like, people like to eat things that taste bad and or taste good and are bad for their health. So, it could be an essential ingredient in some kind of recipe somewhere. Okay, I'm going to start the resolution, do the resolution change to set it correctly while running the video. This is so asking for it, but I think it actually worked. You can't see anything, but it's not nothing to do with that. There, now you can see things. I'm also going to try something. This is an experiment. So the text is really hard to read in the video. There's this program called Script out there, and if you run Script, then it records everything on your terminal unless you SSH somewhere. And if you push like backspace or other control characters, they show up. And so I don't really like it very much. So I'm going to try this. SSH localhost. That's our computer here, SSH to the loopback adapter. And then I'm going to pipe that into T. And I'm going to save this into a file called 430 set 10. And then I have to give my password, which is learn on this machine. Except that maybe I gave it wrong or something like that. No, here we are. Okay, so now watch this. This is like looking in a mirror. Cat 430 set 10. And so you can see this is actually like the stuff I've done so far. And if I cat it again, you can see that on the log here I've catted it twice. And each time you do it, we get like more. If we tail dash F the log, oh, this is probably a bad idea. I can't resist. Okay, tail dash F. You forgot from Linux class, or if you're in it now and I haven't talked about it yet, which I haven't. This follows a file and continually shows you the end of it. But whatever comes out of the file should appear in our log here that we're making as we go. And so what happens? Well, that's kind of predictable. Okay, let's stop doing that. Let's see how big the log is. 430 set 10. It's okay, 71,000 lines. This all was a good exercise, but I think I'm going to just try this again and replace the log. But anyway, so I'm playing with logs over here, and logs are good fun. Everybody likes logs. I don't know why. Okay, and actually that kind of showed up on the video, but not as good as it could. Oh, I was going to explain real quick what desktop environments are, but oh yeah, why not? So this is my desktop environment here. This is rat poison. If you've never used it before, I really like this desktop environment. See, a lot of people, when they have a desktop environment, they lose a certain amount of screen space. So, if you got a screen and your screen is like this big, that's great. And then you have like a bar at the bottom that's like the task bar and start menu and things, and that takes up some space. And then when you take a program and you make it full size, you lose another bar up here that has like, an X and a maximize and a minimize in the corner. And, then the program will have like, some toolbars there. And then the program will have a status bar down here to tell you what's going on. And it'll have a bar of tools at the side. And you can see how your screen space is starting to be reduced here. Maybe it's not quite that dramatic. Whenever I draw the cartoon up here, I make it more dramatic than it is. Screen space is like expensive. And I realized one day the only thing I was using from this thing down here, maybe it has a start. They didn't say start anymore. I don't know. They said start back in the 90s. So anyway, you got some kind of button, and it tells you what you're running, just in case you forgot. And over here you got the time. That was the only thing I actually used from this entire bar. And I realized that in this one up here, the only thing I use from the entire bar is this thing over here. And yet we're going to waste all the screen space from here to here. And so I bought a clock, like, you know, for $5 at Walmart that I put next to my screen. And got rid of that bar. Got rid of that bar because Alt F4 actually does the whole closing it thing. There's not too many circumstances when you want your window to be small. And so, you know, you don't need that bar. They all have shortcuts anyway. And so eventually what you get down to is just this. So as you can see, there's the only screen space that's wasted here is the bottom, and that's deliberate because you can't see it from the back row because people's heads are in the way. So that's the way I prefer to have my user interface. And then everything's available just on keystrokes. You know, if I want to start a terminal, which is about the only thing I ever start, you do that. The other thing I start is a web browser, and you know, you get a keyboard shortcut for that. You use keyboard shortcuts to open and close things, and essentially you never touch the mouse. This is using a program called Rat Poison to manage everything. And it's a reference to the fact that you don't need the rodent that's attached to your computer by a cord. Anyway, so that's an example of a desktop environment. And it's somewhat of a departure from what you see on most computers. On Linux, there's probably at least 4 desktop environments that are popular, not including Rat Poison. Unity, GNOME, KDE, XFCE, and there's probably at least 100 that are unpopular. And they all take care of displaying programs and you know, switching between programs and all that sort of stuff differently. And so you can pick and choose until you find one you like. I used to use Window Maker for a while, and before that I used Fluxbox, and before that I used XFCE, and before that I used KDE. But I've been on Rat Poison for about 5 or 6 years now, and that's the longest I've used any of these. So that's what a desktop environment is. The way it is to display your windows and things and like manage them and whatnot. The actual drawing them, that's different. In Linux, that's handled by the X server, which it just draws windows. Like, it doesn't give you a way to resize them and move them around and things. Okay. So that's how the top part of your operating system goes together. Oh, but I wanted to talk about something else today, I think. And that would be something that we have in the notes. I think we left off last time. We're just about to explain how to write a kernel module. And so that's where we'll start again. Why are the labs missing? Labs are missing. Labs aren't supposed to be missing. That means my notes are going to be missing too. So I'm just going to go ahead and post them. There we go. That should fix it. Hey, there they are. Perfect. Okay, now we got labs, and there are 2 more scavenger hunts. And
Labs said the HTML was not found.
what's not found?
HTML, the lab 2.
Oh.
Yeah.
Oh, I probably didn't add them to the Git repository.
I see.
Oh, there. What? Lab 2.
Lab 2.
And lab 3, and
And then.
okay, there we go. Now they should work. Yeah, now they work. Good. And hey, there's today's notes. Perfect. Okay, they're the same as yesterday's notes because we didn't finish yesterday. And this demo, I never know how long one of these demos is going to take. I don't really expect it to work straight off with no problems at all. And so I didn't plan a whole bunch of stuff that we're not going to probably get to. But there is the risk that the demo will go perfectly. And that really is very risky because part of the point of showing you how to build a kernel module is to show you that everything can go wrong when you build the kernel module, and then you can see that process. If we don't finish it, I'll show you how to use GDB to find a segmentation fault because you'll want to know how to do that for project 1. Okay, so this making a kernel module. Anything else we missed here? Not really. Maybe, but we'll go take care of that later. Okay, so I think this blink.c might already be on this machine. Blink.c. Okay, it's not. Oh, I bet it's on as instructor. wrong password. Type my real password. I always do that by mistake. It doesn't matter if it's not. We can copy it from somewhere. There it is. Okay. So here's a kernel directory that has a few different kernel modules in it. And one of them is blink.c. And so this is not actually something I wrote. In fact, this person wrote it. I don't even know if that's a male or female name in wherever people are named Scarpazza, probably Italy. Anyway, regardless, somebody else wrote it somewhere, and it's under module license GPL. And so GPL license is the same one that the Linux kernel is written using. Basically, it says you can take it, you can use it for anything you like. You can't sue the author if it doesn't work. You know, like if you use this module to control your spaceship and you smash it into the moon, don't go suing him, because the license says that. And finally, if we make some changes of it that are actually useful for something, then we have to go release those changes under the same license. And so this is part of why the Linux kernel is developed the way it has, is this GNU public license, because it means that a company can't take the Linux kernel and improve it and then sell it with their computers without releasing the changes. As in they have to release the changes under the same license, so they can't take it and make it, improve it behind the curtain, so to speak. And so this kind of having all the changes available ends up meaning that the kernel actually improves when companies use it and modify it and so forth. Okay. So we got this under general GNU public license, so I didn't just steal it without permission. We can use it for this purpose with no problem. It's an example module that illustrates use of keyboard LEDs. Your keyboard has little lights on it to tell you if caps lock's on and whatnot. And it's got a scroll lock light on most keyboards. I don't know why they still do it in some ways, but they still do. This modern keyboard over here, you can tell it's modern because computer fashion trends changed away from this like beige color in the late 90s, and black became the new thing, and it's still with us. Eventually we'll be able to date computers from like 2000 to mid-2010s by the black color, because they'll all be orange or something. But anyway, black is still with us. Plus, it has a non-rectangular shape. This was something that came in into 2000s, non-rectangular shapes for common peripherals. Oh, anyway. Yeah, and computers totally have fashion trends. It's a part of life. These things are not designed. The ultimate form of the thing is designed by somebody who's not necessarily a nerd. Okay, so we got this. You got these lights, and this is going to make them blink. Okay, so let me show you kind of how this works from the entry point in it. This is sort of explained in the file inside out, but that'll be fine. Okay, so we're starting with this function here, kbleds init. And it's going to be an initialization function to start up these lights. And if you look down here at the bottom, we're calling this function module init and giving it this kbleds init. This is designating what the initialization is for this module. When you write a module, it has to be in a particular form. You have to call module init and module exit. Both of these functions do whatever you need when your module goes into the kernel and comes back out of the kernel. And you may have to do some other ones depending, but that's kind of the bare minimum there. And so these functions here, kbleds init, it's kind of, it has to be the right sort of function here. And so it's a void function, it takes no parameters. You don't have to spell out void here in C. You could actually do that, and that would be fine. But I guess it makes it clearer. Gives your fingers a little bit extra exercise. Putting void in there is pretty common in a module. Okay, that underscore init. That's going to be defined somewhere in the kernel, and I believe it's a macro of some sort. We'll go find it later. For the moment, it's there. It returns an integer, and it's a static function here. It just means it's going to be it's going to occur once exactly. So this file is compiled, and that's the version of it, and that's the one we're going to have. Okay, so you got this int I here, makes a loop. That's pretty straightforward. So ignoring the print k up there for the moment, this mostly is fairly sensible C. Okay, max in our console, so I'll get to that one in a minute. Okay, this print k thing here. The kernel log on a Linux machine, if you do message, you get the kernel log. And so this includes, for the most part, just stuff that happened. You can see up here all this FGLRX stuff. This is for the ATI video card in this machine. You probably recognize this. The Ethernet 0, the wired adapter link is up at 100 megabits per second. If we go pull the cord out of this thing and plug it back in, we'll probably see a second one of that message down at the bottom. It's having some kind of problem here that has something to do with the common Unix print server. And I won't go through this and figure out what's going on with cups, but there's some kind of problem apparently. There's Bluetooth stuff, etc. NVIDIA line out, line in, etc. You might look at that and think, wait a minute, ATI and NVIDIA, I mean, these are like major competitors in the video card industry. Obviously, every morning they go invade each other's headquarters with rocket launchers, wire their products in the same machine. It's got an NVIDIA chipset on the motherboard here. And so there's it's an AMD processor on this one? Yeah. There's an AMD processor. I realize ATI and AMD are the same company now. There's an AMD processor sitting in a motherboard that's controlled by an NVIDIA chipset, and then you've got an ATI video card plugged into the thing. And it all works. Okay, so yeah, that's all in there, and it's fine. Okay. Maximum main memory for whatever. I don't know what that's. That looks like it's the video card driver is saying, hey, we can go ahead and grab 7,751 megabytes of RAM, which I really hope it doesn't do. Oh, there's stuff from our file system. Recovery, write access will be enabled during recovery, it does that. Orphan cleanup, found one orphan. Computers are different than people. Like normally, if you're going along and you find an orphan, you'd like bring them to the orphanage or adopt them or something like that. In a computer world, we just shoot them. And there's a USB stuff for the new low-speed USB device. That's probably either the USB PS2. Hey, I know what that is. That's this thing right here. It has a PS2 port on one side for the ancient keyboard here. And the other side plugs into the monitor. And we don't actually see anything directly on the ancient keyboard because this thing is making it use the USB bus. Instantly, I keep this thing here. There's all these school shootings these days, and I'm an academic. And in academia, for some reason, we don't like to use firearms to defend ourselves for shooting. So instead, I have this keyboard. If anybody comes in, I'll just throw it at them and they'll die. So now you all feel safe and protected now.
Anti cell phone commercial. Anti-theft protection.
I actually just like the sounds that keyboard makes when you type on it.
Yeah, me too.
My keyboard.
I just have to make up a different reason every day for it. So that doesn't appear anywhere on here. RAID 6. We're using a RAID. We probably have a RAID 6 controller on the motherboard that has one drive plugged into it. And there's its bandwidth. There's Dell USB keyboard. That's the piece of junk over here. That's the modern keyboard. The modern keyboard will not defend you from anybody. You see, this keyboard has a steel backing plate on it. And that's why it's sort of heavy and strong. It still wouldn't stop even like a 9mm or a 22 or anything. But it's just thin metal. But this one here just has a rubber sheet. And it's got dimples on it. It feels all rubbery when you type.
It's still a blunt object though, so if somebody attacks you, you can just hit them with that little socket.
I think it just break.
Oh,
Yeah.
man, for a second.
It'll probably stop at 38 special if it makes you feel like
This thing?
Yeah, calculator can stop it.
Calculator?
Yep, they've shown it.
Well, if that's all it takes to stop it, that would be what to get it. We just need a new law. Shooters have to use a 38 special because it won't penetrate the door either. Okay. Okay, so let's see. TG, this is more stuff on the Ethernet card. AppArmor. SHA-1 policy hashing enabled. I don't know what AppArmor is exactly. Seems to be some kind of a security thing. Oh, hibernation image up front. Oh, it's bringing some unused kernel memory. Hey, that's cool. What else is on this thing? We got some USB stuff for, this is the host controller. So the USB system, it's got a USB chipset that controls all of the USB stuff on the computer. And so that's what we're finding here. And you know, I've been scrolling up here, and so obviously we have to find the USB device that controls the USB system before we can find the USB devices that are plugged into the security system. Or security? USB system. I'm still stuck trying to remember what AppArmor is. So then, you know, I find all that stuff. Here's some stuff earlier on in this system. VISA frame buffer. This is before this GUI has come up. There's more primitive ways to control a video card to get some text and boot screens on the boot up stuff on the screen, and that's what the VISA frame buffer stuff is doing. If you want to switch to it, you push Control Alt and then a terminal number like F1 or F2. I'm not going to do it right now because I am concerned that it'll somehow, the display will come back up funny because I've got a video going and it's using a resolution that Unity doesn't like, and it just strikes me as a recipe for a problem. I will do it at the end. Oh, I was supposed to break this thing at the last time. I forgot.
Yeah, you lied.
Okay, I'll do this now.
You promised us a broken computer.
Okay, what was the end of at the end of the lecture? We didn't hit the ends of the notes, right? Okay, so where I'm going with this whole thing, that's apparently the top. That's the kind of stuff that you see in the kernel log. And so if we go back here, this kernel module is going to throw some stuff into the log about this module loading and something about the console here. And it's going to give us some info as this thing operates. Okay, now this is a very traditional place to put something or other in a module. I noticed there were a lot of modules in there that were reporting having done some mundane task or another. You know, they found something or they're initializing some device or something like that. So that's pretty much kosher there. That's fine. Now, one thing that, you know, we got some extra stuff in here. This is kind of a lot of output for one module. This is a good place to put some debug output when you're working on these things, and it'll show up there in that log that you get by typing the message. Okay, so the kernel module is going to throw a bunch of stuff in that log. Okay. I'm tempted to just go run it at this point and then come back and make some sense out of this in a minute. Timer stuff. Yeah, we'll run it first. Now that you get the basic idea that we're going to be calling this init function, and it'll throw it into the kernel, which will make this init function happen, and you'll see all of this stuff print out. And then we'll come back and look at this one some more. Okay, so as far as getting this thing into the kernel, there's a makefile in here. And it's probably set up wrong at this exact moment. It's set up with KIH being the kernel module that we're going to make. And that's not what we want to make. If we type make, it should probably build it. That's taken forever. But it does look like it actually worked. And it built it on the right kernel headers too. Okay, but we want to make the blink module in here. Okay, KIH is a different one. I'll show you this sometime. This one handles keyboard inputs, or interrupts. Okay, so let's go ahead and make again. And this is one nice thing about it. It really didn't take that long to compile because we're just building that one file there. If we were taking the whole module, it would be longer. Here's a description of compiling the entire kernel. That's a short comic. Okay. So, anyway, that's why I guess it's good to have things that compile fast. I don't know. Okay, so anyway, this thing built. So we have this thing here, blink.ko. You can see here that LD, or linker, was called to make a module, which is going to have some post-linking happen after it's stuffed into the kernel, called blink.ko. And you might recognize .o is something that happens when you compile something into machine code but haven't linked it yet. So you can see we call our compiler here and built this thing, blink.o. And that's our object that's compiled. And then we're going to do some linking with the linker and make it into a kernel object. It's still not an executable, like a program. But it's ready at this point to get mashed into the kernel. So we should be able to say insmod blink.ko. And operation not permitted, okay. Sudo insmod that thing. Learn. Okay. So it's working, basically.
Okay.
And those are blinking. Now, unfortunately, due to the GPL, we can't go make this proprietary and sell it to people for $100 per license. But you know, it's there. Okay, let's look at our kernel log. So you can see we got these KB LED stuff. You can see we're loading it. FG console is 6. That would be the next message down there. And then we print all of these consoles here that were found. I guess we must have that many consoles on this machine at this moment. And I finished them, and it's doing some kind of driver thing. And
Try for magic.
yeah. Well, most of this stuff is magic, you know. All of a sudden, these lights are. You know, the rhythm is weird. Like, look at this. How's my other one doing? Is it the same rhythm? Yeah. I think it's the same.
Morse code.
Yeah. Let me out, I'm trapped in a computer. Hey, whoa, look at this. This thing, is that connected to the computer? What is this thing? Whatever it is blinking too. And I don't think it was blinking before, because I would have noticed that. And it's exactly the same pattern as the others. Okay, so we're blinking that thing and this keyboard and this one. And
I wonder if it'll make all the lights on my keyboard blink. Because it's got a little backlight.
Maybe, I don't know. You can try it. So if you don't like the effect of the blinking lights, incidentally, let me put caps lock here. Okay, so caps lock is on now, but they went back to blinking. So if I push a button, you know, it's like, you know, capital. And I just have to remember that. Okay. So that's great. Let's go ahead and RM mod it. Sudo RM mod. Okay. You can see they are no longer blinking. Is numlock on? No. Numlock is not on. If I turn the light on? Okay, numlock is on. Okay. Just to show you that we're messing things up a lot, I'm going to throw it in here again. We're blinking. And then I'm going to remove it. And we're not. Let's push a key. Numlock is on, but the light's not on. Wow, so I push it. Now the light's still not on, but numlock's not on. So we sort of lose our previous state of these lights. And yeah, okay, let's go to this thing again. There it is. Okay. So what we've done down here, let's see. We're looking through all of these consoles. It seems to have found all the devices that were attached to the computer and had lights on them. Yeah, this is no longer blinking, whatever this thing is. And started blinking their lights. So it's got some kind of discovery process here that's going on. Where's max in our console set? Let's go check. Oops. Okay. Consoles. Okay. So it says for FG console max NR consoles in Linux/tty.c. Okay. I'm going to use the same version of the kernel that we just compiled that module against. That would be version 3.1, 3.0. And whatever Ubuntu version this is, that's the one that's on here. So actually, if you wanted this Ubuntu version, let's say, /etc/app/sources.list. Okay, this is version trusty. And so if we look online, Ubuntu 14.4.3 LTS trusty tar. And so you can download this distribution of Linux here and install it on your computer or virtual machine or whatever, if you want one that matches the lab machines and kernel version, which you might want if you're working on this thing and you want to work at home on it. Okay, anyway, so we got Linux source code here. And it's inside this directory twice, which is weird. Okay. I was gonna fix that, but I'll just leave it for now. Okay. Over in tty.h. Include Linux tty.h. Okay. So somewhere in here it should have that symbol. No, it doesn't. But it includes a whole bunch of other stuff here. You know, TTY driver, etc., etc. Could be in any of those. Instead of searching through all of them like that, let's try this. grep.r what is it? Max in our consoles. Everything in here. Okay. So it looks like there's some mention of it in console struct.h. Extern struct whatever at position max in our consoles. Okay. So that's the only mention of it in the file here. So we're saying extern struct vc vcons, and this looks like array notation here. Like we're going to make one called vc that's vc cons at position max in our consoles. So I would say it's defined somewhere else than that. Let's go a little bit further back in our search. Okay, we'll search the whole include thing. There we go. I see that it is defined as 63. There we go. Okay. So it looks like the max number of consoles here that you can have on it is 63. And if you're root, you can have more of them. I don't think we had 63 on this machine. In fact, I think we had about 6. But apparently you can have 63. I feel like I should show you what we're talking about with virtual consoles here. We're going to risk it on a projector. I'm going to Control-Alt-F1. Log in here. Then I am, in fact, logged in. And you can't see that either, but that's my prompt. I can tell it to the screen in magenta and red. And actually, it looks really pristine on the monitor here. Just looks awful up there. So anyway, we're logged in on a virtual console. If we push Control-F1, we're back to our one we have there. So Control-F1, that's that one that we logged in on, 7. And we're back. So the graphical user interface is running on Virtual Console 7. Let me see real quick if the number was 6 or 7 here. Looks like we got 1, 2, 3, 4, 5, 6, 7 out of 63 maximum. So we've got 7 virtual consoles running on this machine here. And it's gone and discovered all of the consoles. Whoa, this is like, I see a frozen picture of me. I mean,